Thank you for the introduction. This is actually the first time that I speak at a security conference outside of Microsoft. Thank you. And so thank you for the invitation as well and being able to speak here. As you saw from what the bio said, I've been dealing with product security response for quite a while. And I'm here to talk about security response in the OSS context. Before I do that, one other part of my bio is that I am originally from Puerto Rico. The picture that you see here is not Hawaii, it's Puerto Rico. It is very similar to Hawaii, and it's on the Caribbean. So if it's closer to you than Hawaii, and you like Hawaii, great place to go visit. And yes, that is a shameless plug for my island. One of the advantages of going in the afternoon is that I get to build on what other speakers have said. And I will do that intentionally and also unwittingly for some of you that are collaborators with me. This morning, Michael talked about the journey that we are under at Microsoft with regards to building our OSS security program. And he talked about the 4 simple tasks that we have ahead of us. One is identifying the OSS that is being used, cataloging that OSS, and then securing that OSS. I'm here to talk about the 4th one, which is really around how do we respond to security vulnerabilities in OSS. Part of my focus is going to be about multi-party OSS response, but I'm also going to talk about some general OSS response examples. Before I do that, I do want to do a little bit of level setting because I will use some acronyms and they will feature in my slides, so I want to make sure we're all on the same page. The first one is MSRC, which is the organization that I belong to, the Microsoft Security Response Center. We are the organization that has responsibility for protecting customers, protecting Microsoft itself, and protecting our brands. So no pressure for this organization, of course. And you can think of MSRC as well as the next team as the PCERT. Adobe was just speaking for PCERT. That's probably the most common term that is these organizations are known by. The team that I represent, that I lead a portion of, is the vulnerability response and remediation team. We are the team that takes all of those vulnerability reports, whether it's bounty, whether it's customer, or whether it's a security researcher. We run them through our security response process, triaging, assessing, developing, and then obviously releasing a fix. And again, those 2 teams are normally known as PCERT, so you'll see them in my slides. Maybe that's the way you want to think about it as I talk about our program. The next one is also part of MSRC, which is the SERP team. SERP, as you see there, stands for Software and Services Incident Response Plan. We jokingly say that SERP is a noun, a verb, an adjective, and an adverb. It's also a team. This is my previous team. We lead basically tier 3 incident response, so the highest severity response we do from the SERP team. And that might involve some that are strictly product security and some that are also part of what's typically a CSIRT, or computer network security. The last organization that I'll talk about, I'll admit, is a made-up name, the OSS Program Office. That's basically Michael's umbrella organization. He was speaking this morning. I'll refer to them for the benefit of this slide of this presentation as the OSS Program Office. They are a partner and a key component, obviously, in our OSS security program. To talk about our journey, I'd like to start by saying, we've been basically pulled into doing OSS response just because of the transformation that Microsoft has been going on there. And part of that is, obviously, we're releasing a lot more open source than we were doing before, and we're also adopting a lot more open source than we were before. To give you a quick data point, between 2015 and 2017, so 3 inclusive years, we only had 2 high-severity incidents involving OSS. And in the years 2018 and so far in 2019, we have 7 or 8, depending on how you count. So major increase for us in terms of the high severity incidents. That also happens at the mid-level that I'll go into in a minute. So we've had to think about how do we define our response levels as a product security response organization. And the first level for us that we define is simply none. No incident response responsibility for MSRC for what will be that third task in Michael's diagram, which is secure OSS. We consider that kind of rhythm of the business, code hygiene. The OSS program office is managing those vulnerabilities and that process, and maybe we have some documentation that we need to release, but for the most part, we're not engaged. The next level is that high level, which is the SERP, there's a very well-defined criteria for these high risk incidents. The first criteria is anything that's under active attack, whether it's a Microsoft product or an OSS component that we happen to consume. Very clear if it's under active attack, we want to have a very efficient and urgent response. So that's a very clear SERP. Also, any high-risk vulnerability that's either public or about to go public that affects, again, one of our products or one of the components that we use, that also kind of meets that high criteria for high severity will be declared a SERP. And then anything that has high brand risk. So obviously, there's a risk factor here or an axis where we consider the rhythm of the business, secure OSS just to be relatively low risk, code hygiene, normal software development. We have some at the high level that are high risk. And then this is the part that we're kind of fine-tuning still, which is what we call the fuzzy middle. Where is that responsibility where we as a PCERT can add value to OSS response? And I'll be happy to talk to people today in the Luau or later if you have a clear magic formula for where that fits in your organization, because we're certainly still struggling with what is the right balance. And at the end of the day, it becomes a matter of resources. You have limited resources, limited responders, so you cannot just tackle everything. That's why we have the OSS program office building some tooling and some programmatic efforts. But we also cannot treat everything like a SERP. Again, we have limited resources. SERPs are very expensive. So we want to be somewhere in the middle. We know there's some obvious cases, like if a security researcher finds a vulnerability in an open source component and reports that because we are using that component, we are vulnerable, that's very clearly something that we will get engaged. If it's privately reported, no need to be a SERP. We can just manage that through our traditional product security response process. But there are many weird scenarios that we're still struggling with. What is the right level of response? And when we look at that response level, we also see that it's not going to be a very clear one organization has or one team has responsibility for driving it, depending on the severity or the type of issue. But in reality, we are all going to be working together in most of the scenarios. So I try to represent that with this diagram. And I like to say that the bubbles are representative, but in reality they're not, because that orange OSSPO office will be a lot larger. As Michael showed this morning, there's a lot of vulnerabilities that need to be resolved for many of our products, but it just wouldn't work out in the chart. So just think that in relationship, there's a lot more on OSS program office vulnerabilities that they're managing. There's a lot less on the SERP side. Again, the high severity incidents. So that big area of the Venn diagram is obviously that secure OSS tasks that Michael talked about. And those will be managed by the OSS program office. There will be absolutely no MSRC engagement. Now, there is that area where we will interface with the OSS program office. And again, the most common scenario will be a finder that reports a vulnerability in one OSS component. We will use the programs and the tooling built by the OSS program office to find who's vulnerable and then get them into a remediation path. The bullet number 3 there, Michael alluded to it this morning. This is the Microsoft Vulnerability Reporting Program. And it's basically if any engineer or security professional at Microsoft finds a security vulnerability in a third-party component, we don't want them to be reporting to the maintainers or to a different organization if it's not OSS but a third party. We want to manage that through the MSRC. So that's another instance where we take the report from the engineer or the team that found it, and we communicate with the maintainer or with the company to get remediation there. The other 2 areas of overlap is very clear. Hey, there's a high severity incident. We will jointly address this high severity, high risk scenario. And the last one hopefully will disappear over time, which is the scenario of somebody has proven OSS vulnerability affects a Microsoft product, but when we go to the tooling and the catalog of OSS that Michael has built, that team has built, we don't show that we're using that anywhere, so we don't know really the scope of the products that are affected. We might know one instance that was reported to us, but there is more. And that's really the scramble scenario where we need to go find who could be affected in this large software base that we own. So those are the response relationships. Now I'd like to run through some cases just to basically share the lessons that we have learned, as well as the struggles that we have had over this time. And again, I welcome experiences and sharing of ideas when it comes to this. Rather, because I only have limited time, I'm going to start with some of the key takeaways that hopefully you will see in the cases that I'll run through, rather than walk you through the cases and then hope that you extract the lessons. So the first one is, especially when it comes to multi-party response, is be ready to compromise. For example, one very simple instance of that is we have a Patch Tuesday in Microsoft. That's the day we release. Other companies have Patch Wednesday, OEM Mondays. Some companies do it once a quarter. So just in the release timeline perspective, just be ready to compromise, because it will happen when you're working with multiple parties. When it comes to your engineering teams, they're used to receiving a POC. And several speakers have talked about just because there's a vulnerability in an OSS component doesn't mean that your product is affected, or it doesn't mean that the severity is high enough in your product just because the severity is high in the OSS component. That's very real for us. And it's also very expensive and time-consuming to try to figure out what is the actual impact to your product of this third-party OSS dependency that you may have, 3 levels down. So the fact that there is no POC is something that we have had to train our teams to accept, because they're used to having POC for all the traditional vulnerabilities that we get reported. So it's being a culture change. The third one is, especially for multi-party response, is be part of the community. Use events like this to increase your contacts at other companies. Because especially when it's multi-party, a lot of it is dependent on trust. I think you all know in this industry, trust is highly valuable, and we depend on trust in many ways. So use any opportunity you have to build your contacts, develop relationships, because they'll come very, very handy when it comes to multi-party response, and we'll see that in a couple of the examples. There will be inefficiencies to start. I won't go into detail because we're going to see one example of that. OPSEC, personal pet peeve, being involved in multi-party situations where something leaks. That's extremely painful for everybody involved, and nothing will kick you out of the trust circle faster than just not having good OPSEC and having information leak when you're trying to solve a high-severity incident. Somebody else mentioned this, I think it may have been Uber, where they assign like a team owner to a OSS component. We have used this as well, and it's proven helpful for us. I'll actually show one example of this. And the last, stay up to speed with the high-changing OSS world. I don't think I have to tell you that. You probably know this better than I do. If I could add one that I regret not putting there is define your response levels, one of my first slides. Just be very good about defining what are your response levels if you're in the product security response, because again, you have limited resources. You cannot possibly take everything. I'm dying to talk to Christine to understand how they do 900 a year. So I'll be talking to you in the luau, Christine. Okay, so let's run to some cases. I added this one last night based on some discussions that I heard in the conference so far. The issue with Electron here was in 2017, there was a internal demo day, security training day, and one of our red teamers just basically owned one of our products by exploiting an RCE vulnerability in Electron. And we had some of our corporate security folks attending that session, and they immediately email us, say, oh my God, you guys need to declare a SERP or a high-risk incident because of this one demo. And we saw it and we said, no, this is just normal code hygiene. They're using an old version of Electron that just need to update. It's secure OSS. And they came back and said, no, you don't understand. Like, there are multiple products that are using Electron, and they're all very outdated. And they sent us this table, and I changed the name of the products because I didn't want to shame anyone, so I just put the category of product. And they sent us this list, they sent us how old these products or the component that they were using were, and of course, now we had this demo of owning one of our products. And then they said, and by the way, we don't think this is all inclusive, we think there's more. So ultimately, we did declare, again, a high severity incident, a SERP. We uncovered 14 products that were using Electron internally, 6 different versions of Electrons. They were all very outdated, carrying a lot of risk. So we declared an incident with a very clear goal. Let's get all of those products updated to the latest stable version. Let's get some kind of commitment to a maintenance schedule so that we don't get into this situation again. And through that process, we actually had a team step up and said, you know what, we are the most current right now. We have the most vested in this product. We're actually going to maintain a Microsoft build of Electron, and we're going to invest in improving the security guarantees of Electron. And they met with the maintainers, and that's actually worked out really well for us having this approach. It's not mandated that every team has to use it, but it's highly recommended, and many of them have. I don't know if all of them have by this point. So I'll talk about this one. The CVE is related to pub SS. This really falls in the category of not really an OSS issue per se, not really third party, but more about collaboration between private companies, OSS maintainers, and companies that use OSS. And this was an issue that affected really x86 hardware, but it was a bad implementation or a bad understanding of the software development manual of x86 that basically led to an issue in hardware debugs. So we checked the issue with this, interestingly enough, is that somebody in Microsoft discovered this in the summer of 2017, and at that point they said, hey, we cannot take action because we think other parties will be affected. So we really need to coordinate with Linux. We might need to coordinate with hypervisors, etc. And if you know what was happening at the end of 2017, we were all really scrambling with Spectre and Meltdown. We were actually working with a lot of the companies that would be affected by this. So we said, okay, sure, we'll do that, but we kind of parked it priority-wise. And then fast forward to 2018, and in the March timeframe, late March timeframe, we get a notification from Intel, and almost at the same time by the Linux Foundation, saying, hey, we uncovered this issue, we think you're affected. We checked that into the Linux kernel, but you should really look into it. And then we realized, wow, this is a thing that we knew. We've been sitting on this for a while. Now they checked it in, so we're about to be O-Day, and so will many other parties like VMware, Zen, etc. So we need to coordinate together. And that's basically what happened at the end of March, early April. We got a coalition together. We briefed on what the issue was. Locally, they checked in, didn't have a lot of details, and we were able to, all of us, go out together in early May with a fix for this issue. We got a lot of praise from the media as an industry, collaborating together and releasing a fix at the same time. The next issue is ziplib. This one's interesting from the point of view of we got notified in May that the researcher that uncovered this issue was going to go public in June. And it was really interesting report for us because he said, I don't think you're affected, but you have some code snippets in your documentation online in this link that lead me to believe you might want to look into this, at least in your sample code snippets. And that report came in, and if you've been ever in the product security response side, you get a lot of reports that are, really bad quality reports, or there's just not real issues. Here we get one that's not really a report against a product. It's just saying, hey, in this documentation, you have some sample code snippets that illustrate that this condition could be applicable. So we actually had a fault there that we didn't quite know how to handle that issue. The issue got a lot more attention once it became public in June, and we started just asking questions, hey, where is this in the company? And the long story short here is, by the time July came around, we didn't really have a good story about that report and what our impact was. So once again, we declare a SERP, a high severity incident, and through the OSS program office, we couldn't really get much out of the tools that we had. So our team, our .NET team, which was the most knowledgeable and impacted by this, basically built guidance like the one that I'm showing you here on the slide. And we basically had to use all of the incident response teams that we have spread out in the company to try to figure out who is affected by this one issue. And we provided some guidance that you can see there. There was some other guidance in the bottom about next steps and what to do if you thought you were vulnerable. But this is the very high-tech way that we had to go find who was vulnerable. Basically, write a document, email a bunch of teams, have them email other teams until we found one team that was impacted. And we ended up releasing a fix in November of that year. So the issue went public in June. We released a fix for our affected product in November. Certainly not ideal. I'll finish. I think this is the last example that I have. This is another one of those of multi-party coordination. Who here remembers fragment SMAC and segment SMAC? I see a couple nods. So this one's interesting. It's a DOS in the way IP fragments are handled. There's two different ones. We were only affected by the IP one. We were not affected by the TCP one. And this one was interesting because we received the report from the researcher, and we were working it through our normal cycle, which is between 90 to 120 days is when we release fixes for something in the Windows world. So we were working that at our normal pace, thinking, okay, we have time. And then all of a sudden, Google, again, through relationships that we had established with Google, they brought us into this multi-party conversation with other vendors. And it turns out that there was very imminent risk that these issues were going to go public, to the point that all of these companies were planning, and I say companies, I mean NetBSD, FreeBSD, Red Hat, Google, obviously, and many others were planning to go public because they sensed that there was a lot of chatter around this and people were discovering it. And had we not had these relationships established already, we would not have found out, and we will basically have been ODA'd. Now, technically, we still were, but they were kind enough to hold some documentation for the issue that we were affected by until we were able to release in September. We accelerated our cycle. We were able to release in September. Most of them released mostly silently in August. The net result was, for us, we flew under the radar. There was no coverage about us being affected, and there were no attacks against, more importantly, there were no attacks against any of our customers. So overall, a big win, and it was all, again, a result of just having these relationships established and getting early heads up. Oh, I do have one more. RunC, this one was very, very recent. Who here was involved or knows about the RunC issue? Okay, several as well, great. So we were notified by the maintainer on this one. I don't think I have a screenshot here. Yeah, I took it out. It was somewhat similar to the ziplib in the sense of, and again, talking about efficiency, the first ever case that we get for RunC. So we're, as incident responders, product security response professionals, we're like, okay, RunC, I kind of know what that is. So we have to kind of learn what is RunC in the process of responding, and then figure out, okay, who could be affected at Microsoft. We again start that process. This is one where we leverage heavily the OSS program office. And eventually we landed on a very long list of teams that were affected, but in reality, only really one that needed to ship a fix. The other ones just basically needed to patch. And we had 1 month notice, and the message was, hey, we're going to go live in about a month. It was like 3.5 weeks. But we're not sure the date because there are multiple parties that are affected, so we're waiting to hear what is the right date. So obviously you get a message like that, you know that Multiple parties, no, so you need to act fast because there's higher risk that things will go public. But again, you're getting notice ahead of time, so at least you're not getting owed and you can work on accelerated timelines. And ultimately, we were able to release right on time without any major incident. So I'd like to go back to these key takeaways and learnings and just add a little bit more context, and especially with the incidents that we just went through. So be ready to compromise. If you're in a multi-party situation, please be ready to compromise and know that that's the nature of the business. We've been in situations at Microsoft where we have had to release fixes silently, which we hate to do, but we've done it in order to maintain the ecosystem safe. We have had other parties do the same for us. It's kind of the nature of the game, and it works really well to protect, again, the ecosystem. There is no POC. This is more of an internal issue with your teams that you will have to deal with. Especially if they're used to, like our teams are, in receiving a POC, we have a very clear, detailed explanation of the issue. When something hits the fan in the open source world, you will not, more than likely, you will not have a POC to prove that your product is affected, and teams will complain, but you're trying to, again, minimize the potential risk since proving the negative is so hard. Be part of incident response communities. I just went through a few examples of that. A lot of that was actually built because of Spectre and Meltdown, but also just communities like this, knowing the contacts and then developing trust over time, has proven super helpful for us. There will be inefficiencies. I showed the example of the ziplib. We went through the same thing in Run C. It's amazing it's amazing to me anyway, that we still have to do a lot of manual checks and ask people, hey, who do you think is using your product? Because again, we have open source as well and a lot of reuse internally. And sometimes code gets forked, or they don't even fork the code. They just take some code snippets or some code from some component and then incorporate it into theirs. So we're developing relationships with the tools people that do analysis and code searches, but ultimately there are going to be a lot of inefficiencies. Just kind of get ready for that. OPSEC, I won't go into more details there. I mentioned just one example, but again, I think there's more to see here. This is not a universal recommendation, but at least it's proven successful for us in this case and in another, but consider that. And obviously stay on top. Again, I think you know this better than we do. We're still on this journey. But the other one is, again, define your response levels for those of you that are in product security response, because I know you won't be able to do everything. I know we cannot do everything. So I highly recommend define well what your response levels are and what those relationships are between the different teams. So that basically is my talk, and I think I have 5 minutes.
We have a bunch of questions for you.
Oh no. Break. Okay. What is your experience with the disclosure time embargoes? Do they practically work, especially for big multi-party coordinated vulns? How can we do better? Yeah, we've had this debate multiple times and over beers and over conference calls. I personally am a believer of these embargoes. The OPSEC should have probably given you a hint. I think it's the only way. I think nobody likes them. There's a lot of cons against it, but honestly, I don't know of another way to solve a big, complicated security issue that affects multiple parties than to have some sort of embargo. And I also, like my peer at Google, we'd gone back and forth on this, and he had a really good joke about the need for NDAs. And his comment was, has anybody ever been taken to court because they broke an embargo or because it was proven that they broke an NDA as part of multi-party disclosure? And the truth is, I don't know that it has. But ultimately, I think embargoes have a place, and I can't think of another way that we can solve complicated issues without having this shared agreement that we're going to work on it together and we'll go public together, however long it takes us. Incident details are secret. How do you solve teams starting a remediation independently? From a bug bounty report. Unaware of an ongoing incident. Incident details are secret. So if I understand this question, if I don't answer it right, just come see me at the break. So incident details are secret, but ultimately, especially if you're in the product security response organization, you're not the one that's working on a fix. So you need to eventually involve engineering teams that will be working on a fix. So the way we manage this, we do implement information protection controls, and we obviously develop a lot of software around this with SharePoint, etc. So we create tents, for lack of a better word, and we have security groups assigned. So we keep it on a need-to-know basis, and then we apply information protection to make sure that only the people that need to know, and only the people that need to see the information can see it. And they all understand. We reinforce it in every meeting, in every email that we send. We reinforce the need for confidentiality and only need to know. For most cases that are high severity, they're fairly quick to solve. It's very rare, something like the Spectre meltdown, to reference that one. Those are exceptions. There's very few things that take that long. But for the most part, the incidents take a short amount of time. So this is somewhat limited. And again, if I didn't answer your question, please see me. For cross-company collaboration, how much of the communication is through an ISACA versus business social contacts? So I had never done anything to an ISAC. We have used ICASI, which I guess is very similar to an ISAC. We have used ICASI for several incidents. Crack Wireless is one of those that we did through ICASI. But for the most part, there isn't an organization, an ISAC, or even ICASI that incorporates every company that needs to be part of one of these major incidents. If you think about Linux, for example, a lot of the Linux OS vendors, they're not in many of these organizations. So if you need to coordinate with them, with Red Hat, with FreeBSD, etc., you're not going to find them, a lot of them, you're not going to find one of these groups that incorporates all of them. So at the end of the day, you might use one of these organizations, but you might need to invite others to join. We have used CERT in some cases, just to help with coordination. The Fragment SMAC, IP SMAC is one example. Crack Wireless, which wasn't really OSS, but that's another one where we use them. And I think that's it. Perfect.